Hi there, welcome back to the channel. Welcome to the start of a YouTube radio project. This time it's the Braun SK25. It's an AM FM radio. It is minute, it is beautiful, it is incredible, and I'm a fan, you might have noticed. This is the third of three models that came out in that era, the SK2, the SK22, and the SK25. I've done the other two before, hadn't got my hands on one of these, and now I have. These things were designed a long time ago, but if you take them today and put them in an office or a home, it looks like it was designed yesterday. And that characteristic actually extends to a lot of the models they did at the time. They did a world receiver called the T1000 CD, I think it is. They did the Atelier series. I mean, those things are absolutely amazing. Most of those designs are in the Museum of Modern Art as design masterpieces, timeless design masterpieces, and I happen to agree with that. If you like this sort of thing, stick around and enjoy the video. I'm quite a fanboy of these particular models. These came out in the 50s and they were way ahead of their time. I've also done a few in the past. If you've seen my channel, you know I did the SK2B, and then I did the SK2/2, which was a follow-up to that. And of course, I also did the Braun T1000 CD, this latter one being a solid-state world receiver. But the SK25 was missing from my collection to complete that trio of miniature, really small little radios that came out at a time when everything was bulky and everything was big and everything was wood and dark and brown. Not that I have much against that, but I really love this line. There's also my favorite, absolute favorite radio that I've ever restored, which is the Braun Atelier, which was actually launched in the same year that I was born. That thing is amazing. That was a Dieter Rams design, and it was so far ahead of its time, it still looks modern today. But back to this SK25. As I said, this is the third in the range of really small tube radios that came out at the time. The idea was minimalistic, keep it small, keep it simple, and get the quality up. These things are amazing. They were actually in the Museum of Modern Art as industrial masterpieces, and I really think they deserve to be there. Now, this one is not flawless. It's got a few chips on the top right-hand corner, but I'm not too concerned because these cabinets normally get painted, so I'll be using some body filler and sanding it and spray painting it as I've done with the other two. The front, well, yeah, it's a bit faded. I'll probably have to reprint or print another faceplate for that one, and I'm sure it'll come out just fine. The knobs seem to be okay. The actual grille at the front is in perfect condition. Now the back's got a few problems. This is the dipole antenna they have here. Let me get that out. The sockets there are fine, but as usual, this top corner is broken here. I've seen so many of them like this that it's almost like a design flaw. There's a screw missing, and the plug looks fine, looks original. The cord looks fine, and there's a tone control, and we've also got a phono input over here. These two I'm not sure. I think this might be a switch for phono. I'm not sure if the switch at the front will select phono as well. Oh, I think it's a bit stuck. That's turning fine, and that's turning fine. But this one, the selector switch, seems to have something wrong with it. You would select between medium wave and FM, maybe phono as well. So what that is, I don't know. I haven't even looked at the schematic, so I can't tell you whether this had an external switch or not, but I don't think so. Right, but time to get this back off. Shouldn't be too difficult. Just got to remove these two screws and it's done. These screws aren't original either. So let's see what we have here. Well, this wire looks old, but I'm not sure that it's original. This may be a speaker output, and that's just a toggle switch. A bit strange. Maybe, yeah, it could be. Maybe the power switch is broken. I'll find out when I get it out of here. And of course, they made a hole here to fit the switch. It is an old switch, I can tell that, but I'm absolutely certain that Braun did not make that. What a pity. Well, these two I'm just going to cut, and I'll worry about them later. And this is the usual. The cabinet's rather dull, but it's not rust. We've got a lot of dust over here. Nice big transformer. And, oh, what is this? An EL95, now that's unusual. I expected to see an EL84. The other two had EL84s, and that's what I expected to find here. But no, we got a little EL95. Cute little tube. I wonder if this is a push-pull pair. Maybe there's one back there. The output transformer's over there. And we've got the ECC85 tube for the FM. Let's get this chassis out of the cabinet and see what we're facing. Normally these come out quite easily, and they do. That one too, yep. Let's get that dial pointer. And we just push this back. It should come out quite easily. Actually, it's better to do it this way. Less damage. And wow. Wow. This I did not expect. Ha! Look at this thing. It looks like it's just come out of the factory. It looks new. Bloody hell, this is a beautiful looking speaker. All the metalwork is clean. No rust, no tarnish. We've got the dial lamp over there. The FM block is over here. That foam seen better days, but not an issue. But geez, look at this. Look at that transformer. This thing looks like it came out of the factory yesterday. I am gobsmacked. Let's get this out. We've got a little EL95, and it's not push-pull, it's a single tube. I believe this is sort of half of the ELL80, so it's similar to the EL84, but I'm sure there'll be some differences. Yeah, haven't seen many of those around, and we'll take this one out. That's an EABC80 as expected, and that should be an EF89. Yep. Now the front end, we've got our, what is that, ECH81, again as expected, no surprise there. There's our FM tube, ECC85, just got to hold that shield in place. That again, very typical for these radios. All the metal parts on here are really shiny. They look really, really great. Let's have a look on the underside and see if there are any nasty surprises waiting for us. I really hope not. Well, this is a pleasant surprise. This thing has got no paper capacitors. I see the main filter cap over here. And again, this one is very easy to remove because you just unscrew this sort of nut on the side. And then we've got ceramics. Mostly ceramics, a few of these old film ones, but these are generally very good. I will remove one side and check it for leakage and value. But these guys aren't paper caps. They really do work very, very well. What else have we got here? We've got some resistors here that may be a problem. Some of these resistors really go off badly. Let's see, this one here. There are some other ones that are much better, a bit more modern, but some of those definitely go off. They normally go very high in value, so I'll have to check most of the resistors. But paper caps, no, don't see them. There are a couple of electrolytics. There's one there, there's one there. One will be probably the FM discriminator cap, and the other one is the cathode bypass for the power tube. What else do we have here? This guy over here, there's a mustard cap over there. Those normally are pretty good. And the switch, the one that I mentioned is stuck. It's completely open, so it should be quite easy to clean. There's the volume pot and the on-off switch, which I have to check. Yeah, this thing looks really simple. Very, very simple. Very, well, incredibly efficient the way they've done this. And which is one of the things I like about it. These radios they remind me a little bit of those All-American 5s, where you see the underside and there's not much to it. Obviously, there's a lot of stuff on the top side, inside the IF cans and the FM front end, but looking at the underside and seeing this is actually quite a pleasant change. Let me have another look on the top. Yeah, the switch, the mystery of the switch has been solved. It switches off that speaker. You see, it goes to the speaker over there. The output transformer actually provides these two wires with a signal. So this that little socket was for an external speaker. And then this one here switches off the internal speaker when you're using it as an external speaker. It's not even a you know, it's double pole, single pole, double throw. It's just an on-off switch to put the speaker off. So a bit of a shoddy job done here, but fortunately it's quite easy to reverse, and that's what I'm going to do. So I think this guy is pretty close to being switched on for a first test, but the first thing I'm going to do is I'm going to restuff this capacitor with two, what is this, 2 by 50 microfarads, 350 volts. I'll be putting two 47 microfarads at 450 volts in here. I'll remove this, restuff it, and I've done a video where I show how that's done. I'll link it above. And then I'm also going to replace the selenium rectifier, which I think is just a single diode, if I'm not mistaken. I may try something different here. I'll think about it and show you what I decide to do here. So let me get that done, and then we'll see if we're not ready for an actual power-up. All right, folks, some progress. That's been replaced. I restuffed it, and I've shown this so many times I'm not going to do it again. I'll put a link above where you can see the episode on the Back to Basics that deals with this section. Now, here's that diode. This is strange. This is just a diode. That is the, let me see, that is the anode, that's the cathode, that's the anode. It's a bit weird the way they label these things, but you've got to look at the schematic and make a bit of sense as to what's happening, because the AC comes in here, and that is it over here. It's coming from the transformer, okay? And what I've got now is I've put a 1N4007 diode inside here. It's hidden inside the sleeve. I don't want anything shorting. This is temporary, and I'll explain in a second why. And that's going straight to the first filter cap, as you can see in the schematic. So that is rectified, half-wave rectified AC, becomes DC, slightly filtered, probably quite a bit of ripple on there. And then that is the first takeoff point of your B+. So because I've replaced this diode, which is a selenium diode, and you can see this, it says 250 C85. So that's 250 volts, and it's 85 milliamps. I think that's how that works. What I've done is I've actually replaced that with a diode that's got a much smaller voltage drop. That thing's got a 0.7 volts voltage drop, and this guy's probably got about 20, and this is where this degrades quite badly and the voltage starts dropping. Now, I had to figure out what voltage I need, because what I need to do is I'm going to have to put a resistor in series with this diode. Because it's a simple single diode, not a bridge rectifier, I can just put a resistor in series before it gets to the first B+ to drop some voltage. But I need to see first how much voltage I need to drop. And to do that, I'm just going to have to really try this out, because to see the voltage, you need to have all the tubes drawing current. Otherwise, the voltage will be artificially high. So I'm going to bring it up slowly. I'm going to put a dim bulb, my dim bulb tester on there on maximum restriction, which is going to be 40 milliamps, 40 watts restriction. So we won't have any dramatic shorts, hopefully. And we'll see two things. One is we'll see what voltage we get. And two, we'll see whether this thing works. So let me get that set up. Okay, I've got everything ready. I've got the plug connected to the dim bulb tester. I'm going to switch it on here and put it at maximum volume. I'm actually going to put an antenna in here. Let's be optimistic, why not? This has only got one antenna port, and it works for both the AM and the FM. And now, I think we're ready. I put these knobs temporarily on here because I don't want to force the other ones. This is still a bit stiff. I don't know whether it's on AM or FM, but it doesn't matter for now. So I'm going to drop the variac to about 110 volts. Just drop it down a bit, and I'm going to switch this on. There's one light on, all the others are off. That is on. And I can see the dial lamp just briefly, very dimly down there. So that is on. We've got the speaker. I'm just thinking aloud here. And I'm not testing voltages yet. I just want to see if this thing works. So I'm going to up the voltage a bit. Ha! Okay. We're hearing something. So the amplifier is working. Let me switch on the mini whip. I think this is on AM. Very low voltage. The radio is only seeing 158 volts. It's picking up something. think that's the Madeiran, the local radio station. So it's not very sensitive. I'm going to up the voltage a bit with the Variac. Let's take it up to 220. You can hear the volume coming up. It's drawing 100 milliamps. Whoops, that is loud. It's drawing 100 milliamps and the radio is seeing 193 volts. The difference is what's being dropped across the dim bulb, across that lamp. So let's see if it's improved. Not getting much there. Let's try FM. Ha! It's a bit distorted, but it's picking up. Put the mini whip back to FM. I had it on. Okay. Promising. That is very low voltage. Anyway, the point is our radio works and it's drawing 188 volts. Now I'm going to see what voltage I'm getting and what I'm supposed to get. Let me turn this off for now. Our switch is working perfectly, which is great. I've got the two multimeters connected to the two B pluses. The big multimeter, Big Brother, is measuring B1 plus. That's the one coming through the rectifier diode, so across the first filter capacitor. And Little Brother is measuring the second B plus, which is the result of B1 plus going through a resistor to drop it down to the second B plus level. And now we're going to switch it on and keep our eye on the multimeters. Now, what do we expect to see? Well, our schematic doesn't actually give us any voltages on this, which is a bit of a shame. There's absolutely nothing indicated on here that I can see, which is rather unusual. But fortunately, I've got the schematic for the SK2/2, which was the model before this one. Let's have a look at that. Yeah, this schematic is not that good, but we do have voltages. If we look over here, we've got a very similar situation. It uses the EL84, not the EL95, which is the only difference really. But if we follow the first B plus, which comes out of the, well, comes down here through that single diode, it's also got a single diode. It says here 175 volts, which is low, but yeah, that's what it's designed for, 175 volts. And then it goes, there's our first filter cap to ground. It goes in there, through there, and then from there, there's a resistor, 1K, 1 watt, creates our second B plus over here to the second filter cap. And that says, does it say anything? Oh, here it is. It says 150 volts. So I'm going to assume it's the same system. So 175, 150. Now we'll see just what voltage we're getting, because remember, we've removed the selenium diode and we've replaced it with a silicon diode. So this drop across this will be lower, so the voltage will probably be higher. So what I'm going to do is I'm going to switch it on again. I'm leaving the Variac at 220 and I'm going to switch it on again with one dim bulb and we'll see what voltages we get. So there we have it. We've got 220 something volts. It is off at the moment. Now let's go back to here and I'm going to switch it on. It's on FM, I believe. I've actually got this the other way around, I believe. No current being drawn, so they are very similar. And here we go. There's our B1 plus, there's our B2 plus. B2 plus is understandably lower. Put some volume up. Okay, that's on FM. Now I'm seeing 170, 169, 147. These are actually pretty close, but remember, I've got the dim bulbs on. What happens when I remove them? I'm almost afraid to see. This thing's going to go up quite high. But anyway, let me give it another light. And of course, understandably, the voltage goes up. Still receiving 190, 162. Now remember, I've still got only two bulbs, and I've got 220 volts coming in. If I bypass the dim bulb, I'm getting the full 220 going in, and this has gone up way, way higher. And I'm still only on 220 volts AC coming in from the Variac, which means as it stands, let's see what happens if I change it to medium wave. No difference. Okay, well, a little bit of a difference. It's actually gone up. Okay, so I am, what is that, 25 volts over at the moment. And I've got 220 volts, so I'm like another 10, 12 volts below on the AC. So I'm probably going to have to drop about 30 volts. About 30 volts. And do I know what current this thing's drawing? I mean, this diode was rated for 85 milliamps, so I'm going to guess that it's probably about 60, 70 milliamps. I could put a meter in here, but I don't really need to. Okay, so this is what I want to do. I want to drop about, what did I say? 30 volts? About 30 volts. And the easiest way to do that is to desolder that and put a few resistors in series. Just experiment to see which one works best. So I'm just going to use Ohm's law and work out 30 volts at, call it 50 milliamps, and see what resistor I need. Approximately, I can always just adjust it till I get the voltage that I want, and we'll be following that on the meters. Now, this has been set up rather precariously, so don't do this if you're not experienced with this stuff. If you do so, you're doing so at your own risk because we're working with high voltages. I've got the diode over here, right? I've desoldered that from the first filter cap, and I've got a crocodile clip on here. Everything's still off at the moment. That croc clip is coming to one side of a 270 ohm 2 watt resistor. There's high voltage on there and there, so be careful. And the other side, I've got another croc clip going to the B+, the first filter cap, okay? So we've basically set up a 270 ohm dropping resistor, and now we're going to see what voltages we get, and if it's not enough, we can swap that around. And I've got my two multimeters, again measuring the voltages across the two filter caps. All right, let's put it on limit for a change and do that again, just to make sure we don't get anything flying all over the place. Now I'm going to switch on the radio. You can see those caps are still a bit charged. Radio's on. Not drawing current yet. It should start coming down. And we'll see where it comes down to. There we go. Now remember, I've still got the dim bulb in line with two lights, 100 watt total. Okay, that's coming down. And it's receiving on FM. 163, so we're a bit below 175. So now I'm going to bypass the dim bulb. Well, that's about near as damn it. But I'm only seeing, well, I'm only sending 220 something volts. So let me go up to about 230 where this is more, this is where it's mostly at, about 230 volts, 234. It's actually 232 coming out of the Variac, and I'm getting 175. Well, what do you know? That is spot on, first attempt. I promise you, I hadn't tested this before. I do remember that it was about 200 ohms or 200 to 300 ohms. In fact, I remember it was about 200 ohms in the previous ones. And I tried 270 because I wanted to start higher. But that is near as damn it. That's what we need. So I'm looking over here. I've got the dim bulb bypassed, so that's not in effect. There's no limit. And I'm going, and I'm seeing 200, and it's actually 231. If I go to 235 on the Variac, it's now seeing 175. That is perfect. That is bloody perfect. Now, so now I'm measuring, call it 170, 173, and I'm going to go to the other side of this resistor, see what the actual incoming B plus is, and that is 172, 180. It's about 13 volts. But remember, there's a hell of a lot of ripple, so this thing is, yeah, this is not exact. This is not easy to work out. The important thing is, I don't really care too much about anything else. I'm just worried about what the B plus is, and that's what it is. And what I'm getting is 5 point or 4.4 volts AC ripple, which is it's still fairly high, but it seems that this the system is not creating any hum with this kind of voltage. And this is what I'm leaving it at. I'm going to leave it at 270. There's one other voltage I want to check, and that is the heater supply. I want to see what that's at, because that'll be a bit higher as well. So let me see where I can get that. I'll switch this off while I look for it, because I don't want to get zapped. All right, I've just started monitoring the heater supply, and it's at 6.4. Should be 6.3, but this is definitely not a problem. This is at 235 volts coming in. So I don't have to do anything to that. If I had to drop that, if that was far too high, then I would have to have, I would have had to create a dropping of the incoming AC to say 220 from 240 so that I'd get the right heater supply. Because sometimes this thing can go up as high as 7 if you don't do anything to it. So this is the solution. We don't need to do anything to the input side of the main supply. That can be up to 235 without an issue. And what we do need to do is use a 270 ohm resistor. And it's a 2-watt resistor, and I'm going to switch everything off and see what sort of temperature we've got. That is our 270 ohm resistor, and so is this. This is a 120 and a 150. So if you put them in series, you get 270 ohms, same as this one. But the reason I'm using this is because this guy by itself, after I switch it off and try to touch it, it was touchable, but it was pretty warm. I'm sure that this 2 watts would have been enough, but I prefer to use these two together. Now in series, they don't quite make a 4-watt resistor because the 150 ohm will dissipate a bit more heat than the 120. It's simple mathematics. I squared R, same current, different resistance. So one dissipates a bit more than the other, but it does spread the heat a bit more. And as I said, I'm absolutely certain this would be fine, but I don't want something to be hot in there. I need to put a diode in here in series with these two. So it'll be a series chain of diode, resistor, resistor. But I want to put them in here. I want to hide it in here. And this is not difficult to do. All you need to do now is you need to drill out those rivets so this thing can come apart. You flap that back. This is aluminium. It's very, very soft. You sort of flap it back. You put a knife in there or an X-Acto knife and prod that out. Remove all the guts, leave the contacts, and just wire this inside. Now I'm going to break this apart. I won't bore you with all the details. I'll show you the result. Okay, this is what we've got. We've got the diode, a 150 and a 120, so the 270 ohm resistors. This is set up exactly the way that was. So voltage goes in, AC goes in, DC comes out, slightly reduced. And now this has got a mica washer down here, which is an insulator. You've got to be careful. You do not want that to short to the case. And then we've got another protection on here. I probably should put it in the other way. And here we have it. Completely redone, ready to go back into the enclosure with 2 nuts and bolts on there. And of course, I just don't want to fool anybody, so I told them the truth. If anybody opens this up in the future, they'll see that it's been replaced or restuffed. And here we are, folks. That is then exactly where it was before. The wiring is routed or aligned exactly as it was before. I've put 2 little nuts and bolts on here because it had rivets. I'll probably still have to take it out because I want to clean up the back, but I want to test it now. So everything is as it should be. And I've made sure the polarity is right on that diode. It's connected to B+, so it's just a matter of powering it up and measuring the voltage. All right, I'm ready. I've actually put the dim bulb limiter on just for a little while I do the first power on, just in case. And that is normal. It goes up very high before it starts coming down. And we want about 175. It's coming down. I'm going to bypass the limiter. And where is she going to stop? 180. 179. Okay, as it warms up, It's drawing a little bit more current, and that's at 235. 178, pretty good. That is pretty good. Remember that our target was 175, and on B2 Plus our target was 150. Something is wrong. You want to see something weird? This has been off for a while. Let's test the B1 Plus. 85 volts. Now let's test this connection over here. 74, but it's sometimes 74 and sometimes there, 0. Yeah, this wire is messed up. Some strange results, and I'm not sure how long that's been like that. I think, no, when I did the testing with the resistors outside, I was going straight from there. So, yeah, okay. I'm going to replace that wire and see what we can sort out. I'll have to discharge that with my capacitor discharger. Remember this guy? Okay, that should be discharged. Yeah. Replace the wire, see if we can sort that out. Right, that's a take 2. We're back to 174. This is on FM. I'm going to try AM. I think it's slightly different. 148, 149, that's what we had before. 173, 174. Okay, let's try AM. That goes up a little bit. 180, 160. Yeah, I'm happy with that. Brilliant. All right, now that the power supply is done, I should check the amplifier, but I don't need to because I know it's working. I'll go amplifier, then AM, then FM. So I'll move back in the radio, and then there's still alignment to do and the actual cabinet to do, which should be fun. I still have a lot of components to check, a lot of resistors to check, a lot of capacitors to check, even though I think they'll be fine. I still need to check them because right now all I've done really is the power supply. And of course, I've determined that it works on FM and AM, although on AM, reception is not very sensitive. So there's quite a bit to do there, probably a capacitor or two that needs checking or resistors that need replacing. So that's what I'll be doing next. And then I'll come back to you with the result of that, with an alignment and with the cabinet restoration. So for now, I'm relieved this thing's working. It's coming along nicely, and I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Once again, thanks for watching. Bye for now, and most of all, stay safe.